Okay, welcome to Relations and Functions Part 2. And of course, I don't have my page open to the right spot, but we remedied that. So last class we talked about what is a relation. A relation is any set of ordered pairs, like pattern or no pattern. And then specifically, what is a function? A function is a type of relation where each x only maps to one y. And we looked at how to determine if something was a function from like a table, a map, a list of ordered pairs, or from a graph. So we left off with the vertical line test. Now, what we want to cover in this is what we call like function notation and what a function rule is. So your book will talk about writing something called a function rule, and that is just code for equation. Okay, so in your directions, if you are asked to write a function rule, that is just being asked to write an equation. And that's actually I would say equations and graphs are the most common ways that we will see functions. And hopefully we'll get into a little bit of why, why functions are so important. The most common application like for a function is where something is moving across time, and like that whole idea that you can't be two places at the same time. And so that's why a lot of our relationships are functions. Function notation looks like this. We're going to spend some time on this because there's a lot of misconceptions about function notation. And it is something you do need to know. Now, I did not learn function notation until I took Algebra 2. The whole time I was in Algebra 1, my teacher used like y equals mx plus b. We used an x and we used a y, and we never used the function notation. And I just got really good at doing stuff with like y equals mx plus b and doing stuff with my lines. And then when I got to Algebra 2, then my teacher introduced function notation, and I hated it, honestly. And it took a long time for me to realize why function notation was important and the advantage of function notation over just using an x and a y. I know you guys do see function notation in Algebra 1. I like with vertical line tests and stuff, I don't know that it's always really explained well. So you might have heard this. Okay, I'm going to come over here. That f of x is the same as y. And so you might have had a math teacher say that. That's sort of mostly true. If you ever have an f of x in a problem, so if you have f of x equals 2x minus 3, yes, you can take the f of x out and you can replace it with a y if you're more comfortable with that, but it doesn't work the other way around. You cannot take every single y and replace it as an f with an f of x. So if you've had a teacher say this to you, it's because it was useful and quick and easy, but not necessarily because it's true all the time. So you want to kind of get that out of your head. I'm going to make the correction is not the same as y. Like they're not exactly the same thing. So what is this function notation that your teacher didn't like when she had to learn it? It looks like this. The way that you read it, where do we want to start? The way that you read this out loud is like this. I'll put it in quotation. It is read f of x. And so you would have the word of in between there. So you would say f of x. You would not say fx, and you definitely are not going to say f times x, because that is not what it is. It is f of x, and what that is it's a shorthand for saying f is a function of x. You can also think of it as f depends on x. So what are the pieces here? This letter that's out front is just the name of the function. That's all that is. It's the name. So usually when I'm doing this in a live class, I will stop and I'll ask, why do you think that they use the letter F as the name of the function? So I'll wait about 5 or 6 seconds. I know at least some of these classes will be doing this online, so it makes it a little bit more awkward. Okay, if you thought that they named the function f because the word function starts with F, then you would be correct. Mathematicians are known for their creativity. And since the word function starts with F, they name their functions F. Now you can actually name your function anything you want, and I'll give you some examples with that. Now this other piece that we have here in the parentheses, that is just simply the variable that's in your function. And so that's all it is. So you basically, this is an equation. The name of the equation is F, and the variable in the equation is X. So try not to overthink it. I mentioned that that the F was the name. Here are some other common names that you will see a lot. In math class, okay, so we have F of X. Other common names, G of X or H of X. And I'll usually stop here and think, okay, well, why are G and H common names for functions? And if you're thinking because they're the next letters in the alphabet, A, B, C, D, E, F, G, H, you would be correct. That is why. So if we're dealing with a math problem that has more than one function in it, we'll often name the first function F and the second function G and like the third function H, and it's just because we're boring and we don't have anything else to name it. Now, in a science class though, you will run into functions and their names will have more purpose. So let's take a look at this, okay? This might be named V for velocity. And so you would name the function after whatever it is you're measuring. So you have some kind of equation for the velocity. And then your variable here would be time. And what this notation actually means, what you're trying to drive at in your science class, is that the velocity depends on time. The math way of saying that is to say velocity is a function of time, or V of t is how we would say it. So velocity is a function of time. All that means is that velocity depends on the time. If you get into your car and you push on the accelerator and you push on it at a constant, level of pressure, how fast you're going is going to depend on how long you've been pushing on the gas pedal. When you first press on it, it's 0. You're not going. And the longer you press on it, the faster you will go until it levels out. But there's some kind of equation for that. And so in your science classes, you will often use a variable and a name that describe what it is that you're measuring. You can omit the of t. When we get to some of the later things, I'll give you guys permission to just kind of leave that part off, because it does confuse a lot of students. And then this was a trick that I've had teachers do. If you really wanted to, you can name your function, like we could name it Bill of X. So I had a professor that whenever he thought we weren't paying attention, we would get a function named after us. So if I think that you're tuned out or you're looking at your phone or you're doing something that you shouldn't be doing, I will just name a function after you. I used to name them all Bubba, and then a couple of years ago I had a student named Bubba, so I stopped doing that. I don't think I have any students named Bill this year. So you can name your function anything you want. And then remember, it's not multiplication. So I'm going to put that in big capital letters, okay? This is not multiplication. Okay? I actually do want you to write that down. Take a moment and write that down if you're not taking notes. This is not multiplication. It is not F times X. And it's just important to understand what that notation is. So let's look at some directions and some problems. What could you be asked to do with your function? There's several things that you can be asked to do with a function. I think Ms. Braswell, when she teaches this unit, she actually teaches operations on functions at the same time. I do operations on functions in a later unit. But to evaluate a function, what that means is you simply plug in the number and simplify. And if you think back to unit 1, when we talked about evaluate in your first test, you had a problem that you had to evaluate. That's what evaluate means. It means plug in the number and then simplify. So we're going to look at some examples with this. So here is our example function. And we've got f of x equals x squared plus 2x. Now you can, if you wanted to, remember I didn't learn f of x notation until I took algebra 2. If you're more comfortable, you can think of that as y equals x squared plus 2x, where you're going to plug in the input into the function. Remember, just from our last class, when you're dealing with a relation, your x's are your input and your y is your output. And you're being asked to find the y. Now here's what the questions look like. You would be asked to find like f of 3. And again, notice how I'm saying that. Like, I really want you to say it correctly in your head. F of 3. What that means is that you are going to take a 3 and plug it into that function. So we've got f of x equals x squared plus 3. So for x squared plus 2x, I'm looking at the 3. So I'm just going to rewrite that. You don't need to rewrite it if you're following along. So f of 3, what that means is that your x value is equal to 3. So it means plug in x equals 3 and then evaluate. So I'll plug in the 3 right here. And I will also plug in the 3 right here. And then simplify, make sure you follow your order of operations. So f of 3 squared is 9. 2 times 3 is 6, and 9 plus 6 is 15. Let's stop for a second. The way I would read this is it. Like, we're done, okay? If you have gone ahead and you have divided both sides by 3, no, 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 and no again. Erase your work. There is no dividing by 3 because this is not multiplication. And if it's not multiplication, you cannot undo it with division. Division undoes multiplication, but this is not multiplication. So there's no undoing it. This is the end of the problem. I will often put this, like I'll put this on the board. I'll say, stop here. Don't go any further. There's nothing more you can do. You have evaluated the function. You're done. Stop. End. And I say that and I'm emphasizing it. And some of you are wondering why I'm emphasizing it so much. It's because when I look at your work for this, people are going to keep going. Like, a lot of people are going to keep going. And I'm really trying to stop that from happening. Now, to interpret this, what does this mean? Well, it means that when x is equal to 3, y is equal to 15. When the input, when we plug in the x is equal to 3, the output of the function, which is your y, is 15. You could also think of it as this: when x is 3, y is 15. And so you're getting your ordered pair. So there's a bunch of advantages to function notation. I'm going to try to sell you on this, and then I'm probably going to be unsuccessful. But if I were to do the same problem with the x and the y, so I'll just kind of work over here on the right-hand side, where I plug in x is equal to 3, and then we work it out. And we get y is equal to 15. And a lot of you are probably thinking, well, isn't that just as good? Well, I mean, in a way, yes. But notice that, like, when I get to the bottom of the problem, all I really know there is that y is equal to 15. I've lost the x value. In order for me to know the x value, I actually have to look to a different location in the problem that may or may not be easy for me to find. In function notation, you're going to have your x and your y right next to each other. And so you're able to see that ordered pair. Another advantage to function notation is it allows you to work with more than one equation in a problem without confusing your x's and your y's. So if I had another equation that I needed to work with, I could call it g of x. where over here I would be stuck using y and I would have the symbol y and it would mean two different things. So that probably isn't going to convince a lot of you, but yeah, I'm trying. All right, keeping the same function. So f of x equals x squared. What do we have? What was it? X squared plus 2x. Let's look at, we'll do f of negative 1. Okay, and remember, this is f of a negative 1. It is not multiplication. So if I'm going to do this, and again, I'm recopying this just for clarity. This means that x is equal to negative 1, so I'm going to plug in the negative 1. I'll highlight it in a different color just for like super clarity here. All right, now before we go on, notice that I put this in parentheses. This is important. I'll pull up what kind of color can, okay, that is, oh, that's really not what I wanted to do. Important. Okay, it is important that that is in parentheses. So here's why. We'll do like a little sidebar over here. X squared. What that means is x times x. That's what the definition of squaring is. So if x is negative 1, then what I want to have here is negative 1 times negative 1, and a negative times a negative gives me a positive. If you do not put the parentheses there, your calculator will tell you negative 1 instead of positive 1. What it will do is it will square the x, but it won't square the negative. And we want that negative to be squared because it's part of the x. So please be careful with that. I might even emphasize that again on the next slide. So I've already done this part. So we have f of negative 1. Negative 1 squared is 1. 2 times negative 1 is negative 2. And 1 minus 2 is negative 1. And what that means, again, interpreting it, it means when x is negative 1, y is also negative 1. So the point negative 1, if you were to graph that, so if I were to give you the equation y equals x squared plus 2x, and I said, hey, graph that, even though we haven't covered that this year, you would know that the point negative 1 would be on that graph. I do want to emphasize that, and then we'll look at some practice problems, and we'll end the lesson with that. But I want to emphasize this again. If you have x squared, okay, that means x times x. So we'll look at x equals negative 3. We want to square all of the x, because that's what x squared means. And the negative is part of the x. So what we want there is negative 3 times negative 3, which would give us positive 9. If you do it this way, your calculator will give you the positive 9. So you have to have the parentheses there. If you do it like this, okay, this is what you've actually written. In this case, only the 3 is being squared. There's nothing to indicate that I want to square the negative. And so what will happen is you'll do negative of 3 squared, and now you've got negative 3 times positive 3, which will give you a negative 9. They're not the same thing. And I know that can get confusing. It can even get more confusing when you have like a negative in front of the x squared and then you end up with multiple negatives. And, you know, we'll cross that bridge with each problem when we get to it. But this is just super, super important, and it's really common. And if you don't put that into your calculator the right way, your calculator is going to give you the wrong answer, and then you'll wonder what went wrong. All right, last thing is up. I'm going to give you 2 practice problems to work on, and then we will go over them together in class. So we're using the same function here. I'm trying to be consistent. I would like you to find f of 1/2, and you guys are going to love me for that, f of 1/2 and f of 10. Don't be intimidated by the numbers. Math is, oh gosh, a couple years ago I said it so much that the kids started saying it for me. Math is consistent. Like the rules don't change. So just because you don't like the numbers doesn't mean that the rules change at all. So if we're in class, if you're doing this in class, this is the end of the video, and we will finish up the practice by going over it together, whether we're doing it on the dot cam or doing it on the whiteboard. And then for those of you that might be watching at home, I will finish it up on the next slide. Okay, and I say watching at home, but like half of you are watching at home anyway. What I mean is watching it on your own is what I meant to say. So if you are watching this on your own and you're not in class to talk about the review, and it's especially if it's not a recorded session that you can go back and look at, then this is where you get your explanation for it. So for f of 1/2, okay, the rules stay the same. Now I am going to put parentheses around my 1/2 here. I don't really need to, but I'm going to do it just to kind of create the visual grouping of the 1/2 and to indicate that it's not just the 1, it's not just the numerator that I'm squaring there, it is the entire fraction. So don't overthink stuff. Like math is consistent. These rules are consistent. So to square something means to multiply it by itself. So 1/2 squared means 1/2 times 1/2. When you multiply fractions, you multiply straight across. So 1 times 1 is 1, and 2 times 2 is 4, and so 1/2 squared is 1/4. And I'm going to go ahead and erase my scratch work here, just because I don't want to clutter up my screen too much. And I'll bring this down. Okay, and then let's take a look at the 2 times 1/2. 2 times 1/2. Well, remember that 2 it can be written as a fraction. It's a rational number, so you could write it as 2 over 2 or 2 over 1, and then multiply straight across. So 2 times 1 is 2, and then across the bottom 1 times 2 is 2, and 2 divided by 2 is 1. And again, I'll erase my scratch work over there. And now we have 1 plus 1/4. So you got some options here. I'm going to go through the calculations just because I think it's a good little review for your fraction arithmetic, but we'll talk about some other options you might have. If you want to add fractions, this is one of the most pain in the neck kinds of things to do. Multiplying fractions is nice and easy. We just did it. You multiply straight across. When you are adding fractions, that's when you need to have a common denominator. So the key here is to take the 1 and write it with a denominator of 4. Now remember that 1 is a rational number, which means it can be written as a fraction. It's not, and we usually don't want it to be, but we could write it as a fraction. So what I want to find out is what version of that fraction will give me the common denominator of 4. And that would be 4 over 4. So remember our nice structure to our problems, top to bottom? If you're wondering where did 4 over 4 come from, I just rewrote the 1. 1 is equal to 4 over 4. And now when you add them, you add the numerators and you hold the denominator constant. So 1 plus 4 is 5. And we hold the 1/4 plus 4/4 gives us 5/4. And so my final answer here would be 5/4. Now you do have some other options there. So if you could, now you can use your calculator to do this, and I'm actually a pretty big advocate of that. You have a calculator that will totally do your fractions for you, and that's something that maybe we could do in a tutoring session if you're interested in how do I use my calculator to do this because I don't like it. You could also do this. So here's some other ideas. I hate mixed numbers, but you could say 1 1/4. So the only place I've ever really seen mixed numbers used is in cooking. So if you have 1/4 of a cup of flour plus a cup of flour, then you have 1 1/4 cups of flour. I don't like that. Another option is to convert it over to a decimal. So 1/4 is 0.25, and so you could give your answer as a decimal. Just make sure you read the directions. The directions will sometimes tell you what form you need to leave your answer in. All right, and I think the last one, I think this one is a little bit better. So this was f of 10, And so we have 10 squared plus 2 times 10. 10 squared is 100, 2 times 10 is 20, and f of 10 is equal to 120. Now, I think just because if you're watching this on your own, I have a bit of a captive audience. So suppose you were asked to graph this. So x squared plus 2x. And we can look at the y version of it if you'd prefer. So you have the x and the y axis. What we have successfully done here is we've actually found a bunch of ordered pairs. If I go back to that first problem, when we plugged in a 3, we got 15. When we plugged in a -1, we got -1. When we plugged in the 1/2, we got, I'll say 1.25. And then when we plug in a 10, we get a 120. What we could do is plot all of these points on my XY graph here, coordinate plane, and we would get points that are on the graph for that. And so like -1, -1 might be there, 315 might be here, 1/2, 1.5, 10, 1, what? Okay, it's back. Yay. And then you could try to connect them. Now, this actually is going to look something like that, and we didn't really pick enough points to be able to see that. But since you're watching this, it's nice to be able to see how you go through that process of picking points. You plug them into your equation, and then you get these points. And if you pick enough of the points, so we only did 4, but if you pick enough of them, then you get enough to be able to sketch the entire graph.